Hello, my dear students. How are you all? I hope all are good. Welcome back to today's session. My dear students, I am very happy to see you guys attending for classes regularly. In last class, I hope many of you have attended. Hello. Hi, good morning, one and all. Hi, very good to see you for today's class. Wow, good. Sushruth, Pukya, and many more names are coming. Good morning, good morning, good morning, good morning. Hi, I'm very, very happy. Like students are giving responses. Nice. Okay, let me summarize quickly within 1 or 2 points. If any student who has not attended last classes, so let me brief few things. In previous classes, we have discussed mainly about matter and its classification and various categories of discussion we have done, and I have given examples for various categories also, right? Yeah, good. Chemical classification of matter we have studied in last class. Okay, now in today's session we are going to study very important topic in chemistry. As I already told, we haven't started the chapter yet. We are actually discussing the basic definitions and terms and concepts, right? Today's session, as I told you, it is going to be very important. As chemistry students, when you are studying chemistry, we will come across with various formulae and names of compounds. As far as my knowledge is concerned, as I have observed for these many years, students may faces difficulties in naming the compounds and writing the formulae of the compounds. My dear students, the topics are there. We will be studying in future classes. So one of you are asking about the mole concept and many other topics we will be studying in future classes, right? So today's session we are going to study about basic inorganic nomenclature. When I refer the word nomenclature, people always think about organic compounds. So for organic compounds also we have IUPAC nomenclature, but the rules and regulations are a bit different for organic compounds. We have even the IUPAC nomenclature for organic compounds also in upcoming classes. Today I'll be starting about the inorganic nomenclature. So are you ready? So please students, so listen properly, follow the things properly. Wherever it is required, please note down the points. Okay. So without further delay, I am going to start today's session. Today's topic is BIN. BIN. Sir, what is this BIN? BIN. BIN means basic inorganic nomenclature. In other words, we can say this topic is all about studying naming of some important inorganic compounds, right? So we will be dealing with BIN, it means basic inorganic nomenclature. In other words, we have concluded this as naming of inorganic compounds. Okay. So under this, we will be studying about, let me brief out things which we will be studying in this class. We will study about naming of metals, we will be studying about naming of non-metals, and third subheading is naming of cations, and the fourth one naming of anions. And lastly, after knowing information about naming of cations and anions, we will try to write the formulae of inorganic compounds. Right? Students, please focus the class. Listen the class properly. Don't be diverted with anything. Concentrate on the class. Okay, fine. So today we will be studying about naming of metals, naming of non-metals, and naming of cations, anions, and formulae of inorganic compounds, and of course their naming also. It includes acids may come, bases may come, and even salts also will be there, right? So in today's session, we will be studying about naming of important inorganic compounds. Let's start the first one, naming of metals. You may think like, sir, what is there in naming of metals? We know everything, all the metals names we know, and everything you may think like you know the names of metal. But there are some students, they may confuse about the metals and non-metals, and they will not be able to identify the difference between metals and non-metals, and they can't be able to write their names, right? Therefore, here if you consider the metals, majority of the metals are suffixed with, if you consider, for example, sodium, magnesium, potassium, calcium. Like if you can write the list of metals, usually metals are suffixed with IUM. Then how to identify whether a given element is a metal or not? Okay, so usually metals names are suffixed with IUM. Let me give a few examples. So what is the name of an element which is written with symbol Na? Can anyone tell me? This is sodium. Of course, there is a Latin name for sodium also. Can anyone tell me what is the Latin name of sodium? Response please. Latin name of the sodium. Latin name of sodium. So people are saying, people are giving names only sodium, sodium, sodium. Yes, very good. natrium. Okay. Even this word is also suffixed with IUM. I am going to list few more elements like potassium, K, potassium, and Ca, calcium, right, Mg, magnesium. Like you can write the list of elements. Okay. Then can anyone tell me the Latin word which is related to K? Kalium. Okay. So this is magnesium. So if we can conclude, the metal names are usually suffixed with IUM. And there are some metals, they may not fall into this category. For example, second part under this is, if you take, let's say, Fe and Cu, Au. These metals were actually used during ancient times and the names were derived during that time also. So Fe is called as iron and this is copper. And what is name of Au? We can write it as gold. Of course, there are Latin words also for these elements. Yes, ferrum and cuprum, and this is aurum. Students, let me conclude the naming of metals. So usually metal names are suffixed with IUM. Majority of the metals are falling into this category. Like I have given the list like sodium, potassium, calcium, magnesium, aluminium, rubidium, cesium, francium, calcium, strontium, barium. So all these names of the metals are suffixed with IUM. There are other categories of metals, they were actually used during the ancient times. They have derived the words in a different manner. So Fe, the name is iron, and copper for Cu, and gold for Au. And there are Latin names also for certain elements such as Fe, which is derived from the Latin word ferrum, and Cu, cuprum, and for Au, aurum. Can anyone tell me the Latin word from which the SN was derived, and PB also I need? So students, response please. SN. What is the Latin word for SN? Right? Very good. Chandu. Sternum. What is the Latin word for PB? Plumbum. And SN can also be named as tin, and PB can also be named as lead. And dear students, I need the Latin word from which these elements were derived. W and Hg. W means tungsten, and the Latin word for W I need. Good, good. Wolfram night, rice, nice. And what is the Latin word for Hg? Hydrogenum. Very nice. So students, there are some metals or there are some elements which can be derived from or which was derived from the Latin words. There are many elements that we have considered here. K, the Latin word is kalium, and then for sodium, natrium, and ferrum, cuprum, aurum, and stannum, and plumbum, and wolfram, and hydrogenum. These metals were actually derived from the Latin words. So with this I am going to conclude the names of the metals. Okay, I hope this is clear to everyone. Fine. Next, we are going to start the naming of non-metals. Naming of non-metals. Usually non-metals are suffixed with, I am going to write some hints. Non-metals such as, let's say, argon, ON. I'll give you examples. There are some hints for INE, GEN. These are the hints which can be written with the non-metals. So where we can use actually what kind of elements comes under this category? If you say examples, argon, krypton, argon, krypton. If you observe these elements are actually suffixed with ON. And if you consider fluorine, bromine, iodine, these non-metals are actually suffixed with INE. There are certain non-metals which can be even suffixed with GEN. Let's say hydrogen, hydrogen, oxygen, oxygen, nitrogen. I hope these points are clear. So let me conclude, my dear students. Non-metals are usually suffixed with, if you find the last letters of non-metals, they may be suffixed with, or they may be ended with ON, or they may be ended with INE, and they may be ended with GEN. Fine. Okay. So therefore, the naming of non-metals you can easily identify if the last two letters or three letters of an element is ended with either ON or INE or GN. We can categorize such elements under non-metals. Is this point clear, dear students? Right? Of course, I can say one thing. All elements may not fall into this category, but majority of the elements can be falling into this category. Therefore, we can say, if in order to identify a non-metal, you will observe the end part of the name is suffixed with either ON or INE or GEN. This is about the naming of non-metals. Coming to the naming of cations. So, what is cation? Can anyone tell me what is cation? Cation. Anyone please? So, if you take an atom can give either cation or anion. Atom is a neutral species. Right? Good. Now, if you take an atom and by removal of electrons or loss of electrons, by loss of electrons, you will get a cation. Cation is usually having what charge? It is carried with positive charge. And what about anion? Anion is obtained by addition of electron or gaining of electrons. Addition or gain of electron. A negatively charged species obtained by gain of electrons is called as anion. Is this point clear, dear students? This is just a basic point. As everyone knows, I think you might have studied all the points in your lower sections, lower classes, right? So atom is a neutral particle or neutral species. So from this atom, by removal of electrons, you will get a cation, and by gaining of electrons, you will get anion. Okay. Now we will be starting about naming of cations. Fine. So here to students, now let me take an example. With an illustration example, I will discuss. Look at carefully. Let's take sodium. Can anyone tell me atomic number of sodium? What is atomic number of sodium? Atomic number of sodium is 11. 11. It means how many protons are present inside the nucleus of sodium? Number of protons are 11 and number of electrons are also 11. Total number of protons is equal to total number of electrons in a neutral species. Good, many are giving answers, right? So total number of protons are equal to 11 and number of electrons are also equal to 11. So total positive is balanced with total negative charge. That is the reason why this is neutral species. What I am trying to do, from this sodium atom, I have removed an electron. Now in Na plus, this is called as sodium ion. And of course, as everyone knows, this is sodium. So from sodium, if you remove an electron, it gives sodium ion. Now in the sodium ion, how many protons are present and how many electrons are present? Response please. How many protons are present and how many electrons are present? So I have not disturbed the number of protons. Even in sodium ion also number of protons are 11. And how many electrons are present in sodium ion? How many electrons are present in sodium ion? It is a simple point. So from 11 electrons I have removed an electron. Then how many electrons are left? 10 electrons are left. So that is the reason why this ion carries net positive charge. Hence this ion is a cation, and which is a positively charged species. Next, coming to the example of chlorine. Chlorine atomic number is 17, and by adding one electron into chlorine, it gives Cl minus. Now here, this species carries net negative charge. That is the reason why this species is called as anion. And name of this anion is chloride ion. Chloride ion. Now in this example, chlorine has total number of protons is equal to 17 and total number of electrons is equal to 17. Now in the anionic part, in chloride ion, total number of protons and total number of electrons are equal to. Tell me students, very good. Total number of protons are 17 only, but the total number of electrons are coming as 18. Therefore, if you observe here, total number of protons count is 17 and total number of electrons are 18. Then who is dominating now? There is net negative charge. That is the reason why this species is called as anion and this species is called as cation. I hope this point is clear to everyone. Good. Now if you talk about the cation, total number of protons is equal to total number of electrons. But when it comes to the anion, total number of protons is less than total number of electrons. That is the reason why there is net negative charge on the anionic part and there is net positive charge on cationic part. I hope this point is clear to everyone. If these things are fine, if this is clear, we will move on to the next point. Now coming to naming of cation. As we were in this part only, naming of cation. For the sake of convenience, I am classifying the cations into three categories. Cation which carries only single positive charge. Cation which carries only single positive charge. Examples, if you take for example Na plus, Mg plus 2, Al 3 plus and K plus, etc., you can write anything, calcium plus 2. So all these names are usually suffixed with IUM. So name of a cation which is carried with single positive charge usually suffixed with IUM, and at the end of the name anyway we will write it as ion. So for example, this cation is named as sodium ion and this is magnesium ion and this is aluminum ion and potassium ion and this is calcium ion, etc. And the list is adding on many more. So we are not doing anything. Just the name of the metal is suffixed with IUM. Name of the metal as it is. At the end of the name, we are writing a term as ion because this is carrying charge. Is this point clear, dear students? Is this point clear to everyone? So, when you are writing the cation name of the metal, it is written as it is. At the end of the name, you are just attaching with a term ion. This is about the cations which carries only single positive charge. Coming to the second part, cations which contains, this is very important, listen properly, contains more than one positive charge. More than one positive charge. We can write another word for this is variable valency. Variable valency. It means the same element, same metal can be able to show two different charges or two different oxidation numbers. So here I have introduced a term which is called as oxidation number or oxidation state. Oxidation state. Oxidation number or oxidation state is defined as the charge which is present over the ion, simply. Charge on the ion itself. Later on we will be discussing about definitions, how to calculate oxidation state, all the stuff we will be studying. So let me write examples for this category. Dear students, this is well-known example Fe plus 2 and Fe plus 3. Usually in this case, the same element or same metal carries two different charges or two different oxidation numbers. Usually the metal which is carrying lower oxidation state is suffixed with OUS. This is called as ferrous and this can be named as ferric. Understood? Next one, another example for this category be Sn plus 2, Sn plus 4. I hope you are able to name this species. This can be called as stannous. The element which carries more positive charge is considered as stannic. In the same manner, Pb plus 2, Pb plus 4, plumbous, plumbic. I hope this point is clear. In any case, the same element carries two different oxidation state. Usually, The one with lower positive charge or lower oxidation state is suffixed with OUS. OUS. The one with higher oxidation state is suffixed with EK. It was repeated even for these examples also. Yeah, superb. You can also add in this list. You can add. Good. Cu plus and Cu plus 2. Cuprous. And this is cupric. Students, I wanted to give an example. You guys have to answer this example. Be ready with your answers. Hg plus 2 and Hg2 2 plus. So ready for answer this question. Yeah, tell me. Name Hg plus 2 and Hg2 2 plus. Hg plus 2, here Hg carries more positive charge. That is the reason why this is called as mercuric. And this is considered as mercurous. Very good. So the above one is called as mercury and Hg2 2 plus is called as, yeah, you can also name it as hydrogeric and hydrogerous, but it is not much good. Okay, this name seems to be good. Okay, so with this I wanted to close the naming of metal which carries single positive charge, and we have named the metals which carries more than one positive charge. The zinc shows, I think someone is saying zinc shows only one positive oxidation state. Okay, now going to the next point. Now the third case under this is if non-metal carries positive charge. Non-metal carries positive charge. If non-metals carries positive charge. Okay, for example, let me write with an example. NH4 positive. Here group of non-metals you can say, or group of non-metals carries positive charge. Yes, my dear students, NH4 plus can be named as NH4 plus can be named as NH4 plus can be named as ammonium. Okay, I am going to add in this list. H3O plus is called as hydronium. And we have other names to NH3 positive NH2. This is called as hydrogenium. And in the same manner, you can also write C6H5. There are other names also. This is actually called as aniline, which is very important organic compound, and cationic part of aniline is called as anilinium ion. And the last one, this compound is called as pyridine. So cationic part of pyridine is called as pyridinium ion. Okay. Now students, I have given 3 types of naming of cations. Okay. The first one, if a metal carries single positive charge. In such cases, name of the metal we have written as it is, and at the end of the name ion we attached. Second consideration, we have named the metals which carries more than one positive charge. In such cases, in general, The metal with lower oxidation state we have called as Us, and the higher one is called as Ik. Like for example, Cu plus 2 and Cu plus 1. Cu plus 2 is higher version Ik, and plus 1 is lower oxidation state, we have named it as Us. And in case of a non-metal carries positive charge, in this case we have suffixed again with IUM only. Here if you observe each and every name, IUM, 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 and here also IUM. Okay, points are clear. Shall we move forward? Yes, tell me doubt. Okay, Chandu. Hi Chandu, tell me your doubt. Fine. Shall we move forward? This is about naming of cations. Move on to the naming of anions. Students, if someone wanted to note down, so you can, I think while taking the class you can note down, otherwise after completion of the class also you can just check the points. You can easily write after completion of the class. Okay, good. Next, move on to the next. This is the fourth one, is very important, my dear students. Very important. Naming of anions. Naming of anions. So dear students, with this point we will be continuing naming of anions. Usually names of anions are derived from acids. Names of anions are actually derived from names of acids. So if you talk about an acid, what is an acid? There are various definitions. In our 11th standard, we will study about theories of acids and bases. There we will study important theories. I hope you guys have already aware of the basic definition of acid. We don't want to taste the substance. Some people can say, so acid is a substance which is taste wise we can say, and you cannot taste for all the substances. Okay, fine. Okay, naming of anions is actually derived from the acid. Now when you refer about acid, acid is a substance, the basic definition, which donates or which produces H plus ions. There are other definitions too, where there are various definitions of acid also, but for our discussion only this definition suits. And we will study the other classification of acids in other classes also, right? Next, so coming to the acids, classification of acids. Why we are actually classifying the acids for naming of anions? As I told you, the names of anions were derived from the acid itself. For example, HCl, this is hydrochloric acid, and Cl minus, which is produced by removal of H plus ion, is called as chloride ion. Okay. Now in this case we have to discuss about the classification of acids. Now acids were broadly classified into two categories. One is hydroacids and the second version is oxyacids. What are hydroacids? In these acids, hydrogen is present and other non-metal. Hydrogen and non-metals other than instead of writing hydrogen and a non-metal without oxygen. Okay. Now, when it comes to oxyacids, hydrogen is present and oxygen is present and other non-metals too present. Non-metal or even a metal is also present or a metal. So, what is difference between hydroacids and oxyacids? In hydroacids, hydrogen is present, hydrogen along with a non-metal. But when it comes to oxyacid, hydrogen and oxygen must be present. There would be a presence of non-metal, or sometimes you may find metal also. Okay. So, when it comes to hydroacids, tell me students examples about hydroacids. Examples please. HCl, HBr, HI, HF. You can also add in this list HCN and you can also write H2S. In all these acids, we will observe hydrogen along with a non-metal. Usually these non-metals mostly 17th group elements, halogens. Okay. So here HCl can be named as hydrochloric acid. Names of these acids I think everyone knows. Hydrobromic acid, hydroiodic acid, hydrofluoric acid, and this is called as hydrocyanic acid, and this is hydrosulfuric acid. Then how to write the anionic part of these acids? If you observe students, now how to write the anion which is derived from these acids. Now this point is very important. If you talk about just remove H plus ion of these acids, you will get anion which is usually suffixed with IDE. Okay. Now students, we will come to later on about nitric acid, sulfuric acid, all this stuff. Now, I wanted you guys to name the anions which are derived from hydroacid. If you derive anion from these hydroacids, now here I am writing anion, just remove H plus ion. If you remove H plus ion of this acid, you will get Cl minus, and here Br minus, and I minus, and F minus, Cn minus, and even S2 minus also. Students, name these anions. Now, all the anions, if you observe carefully, anions are usually suffixed with IDE if it is derived from hydroacid. Fine. Now, tell me the name of this anion. Chloride, and this is bromide, and this is iodide, fluoride, cyanide, sulfide. Okay. When you are naming the anions which are derived from hydroacids, it should be suffixed with IDE. Examples also I have given. Then what about the anions which are derived from oxyacids? Can you name any oxyacid? Oxyacid, as I told, in these acids you will find hydrogen, oxygen, and a non-metal is present. Some cases you may find even a metal also. Fine. Now let me give an example. H2CO3. Can anyone name the acid which I have given? H2SO3, H2SO4, HNO2, HNO3, and so on. We will add up in the list. Now tell me names of these acids. First of all, this acid is called as carbonic acid. Next, Yeah, we will write all the acids and naming of acids also we will do in a better manner. Okay. Now let me finish with these examples. Can anyone name the H2SO3? This is sulfurous acid, sulfurous acid, and this is well known and very familiar acid. In fact, this is also called as king of chemicals also. H2SO4 is called as sulfuric acid, and HNO2 is nitrous acid, and HNO3 is nitric acid. So nice. Very good, very good. Good. Now I have given the names of acid. Students, believe me and trust me. So we are going to deal the names of anions in a different manner. So in majority of the platforms, you may find like just they'll dump the anions list and cations list. They'll ask us to write the formulae of the compounds. With this method, you may confuse about the names of anions, but I am going to give in a different manner. Names of the anions you will never ever forget if you follow the procedure which I am going to give. That is the reason why next class is going to be very interesting class and very important class. My dear students, please don't miss the class. Upcoming class is going to be very important. In the beginning of the class, as I mentioned already, people who are finding difficulties in learning chemistry means those people are not actually aware of writing the formulas and naming the compounds. Even organic chemistry also, when you are studying organic chemistry, majority of the people find difficulties in writing the formula of the compound and naming the compounds. That is the reason why my best advice I can give for you guys is people who are thorough with naming of compounds and formulae of the compounds can study properly. So in today's session, just I wanted to summarize within 2 points. Listen, my dear students, carefully. If anyone has missed the continuity, listen classes, listen properly, please stop the chat box, please stop chatting in the chat box and listen couple of minutes which I am going to explain. My dear students, today I have started the introduction about naming of inorganic compounds, right? When you are naming inorganic compounds, you need to know the names of cations basically and anions, right? So with this, if you observe carefully, cations were actually formed from metals itself. If you observe cations, whatever list I have given, those are actually metals only, the metals which carries positive charge. I have given 3 categories of cations. First type of cation is metal with only single positive charge. Second version of cation is metal with same metal with two different oxidation numbers. In such cases, the metal with lower positive charge is suffixed with OUS and metal with higher positive charge is suffixed with IC, that means IC. An example, let's take an example. Cu plus and Cu plus 2. Cu plus means lower oxidation state is named as cuprous, and Cu2 plus, since it is having higher positive charge, which is called as cupric. Next, afterwards, I have given the third category. If a non-metal or collection of non-metals carries positive charge, such positive charge is usually suffixed with IUM. Like an example, NH4 plus, ammonium ion. And we have started naming anions. In order to name the anions, one must know the origin of acid. So means the anion which is derived from a particular acid. If you are aware of the list of acids, you can easily name the anions. Students, I have given just a few examples for acids, then how to obtain the anions from these acids and how to name these names of these anions we will be studying in upcoming class. My dear students, please don't miss the class which I am going to explain in the tomorrow's class. So with this, I wanted to close. My dear students, if you are just taking the class, please request is subscribe the channel, and if you like the video, please forward to your near and dear friends so that many people can be benefited by taking the classes. With this, I wanted to wind up today's class. Thank you. That's all for today.